Welcome once again. In this video, I would like to explain about the sections of solids and the development of solids. Generally, solids are divided into two groups, Group A and Group B. Group A solids are solids that having top and base of same shape. The Group B solids having base of some shape and just a point as a top called apex. Examples for Group A solids: a cylinder have the same shape at the bottom and at the base and top. Prisms, a triangular prism, same shape at the base and top. Square prism, pentagonal prism, hexagonal prism, etc. Cube is also a solid having 6 faces. Cone is an example of type B or Group B solid. Pyramids, triangular, square, pentagonal and hexagonal pyramids. These are type B solids. These are having a base and an apex only. Another type of solid is tetrahedron, which consists of 4 triangular faces. One triangle at the bottom and 3 on sides. The dimensional parameters of different solids. This is the top. And the rectangular face, it has 4 rectangular face for square prism. Longer edge, corner of base, edge of base and base. In the case of a square pyramid, this point is called the apex. This is slant edge. This is the base and base edge. There is a corner of base. Triangular face. It has 4 triangular faces. A cylinder and a cone. These are formed by generators. Generators are imaginary lines which are used to generate the solid like a cylinder and a cone. It has a base and a top for the cylinder. For a cone, there is a base and an apex. This is the sectional use of some solids. First is a cone, second is a cylinder, and third is a square. A square pyramid. For this is square pyramid. And when it is cut by inclined planes, in the case of first 2 cases, we get an elliptical shape. These are called frustum of cone and pyramids. Here, the cutting plane is parallel to the base. In the first case, the cutting planes are inclined to the base. That is the difference. So, in this session, we discuss about sections of solids and development of the sectioned solids. Before entering into next session, we shall discuss about a section plane. The case of A, type A, this is a section plane which is perpendicular to VP but inclined to HP, or we can say it is an auxiliary inclined plane. So in the front view, the section plane will look like as a line. In the second figure, the cone is cut by a plane which is inclined to VP and perpendicular to HP. In top view, we get the section plane as a line. Some points to remember: after launching a section plane, either in front view or top view, the part towards observer is assumed to be removed. As far as possible, the smaller part is assumed to be removed. That is, in the case of figure A, the top portion of the cone, which is a smaller portion, during section this will be removed and the sectioned view will be shown in the top view and in side view. In the case of figure B, it is sectioned like this. So the smaller portion is removed. If you want to see the section portion, it is shown in the front view, and we get its side view. We have to draw the side view to get the details. The first four figures are the section of a cone. This is the section plane. When it is cut through the apex, we get a triangle at this face. When it is cut by a section plane like this, we get the shape of an ellipse. If the section plane is passing like this, we get the shape of a parabola. If the section plane is parallel to the axis and like this, we get a hyperbola. When a cylinder is cut in this direction, we get the shape of an ellipse. And when the square pyramid is sectioned through this plane, we get a trapezium. These are the important terms to be studied before going to the sections of solids. So this is the front view, this is the top view or sectional top view. Here, this is the section plane. The section plane is perpendicular to VP but inclined at an angle with the HP. So we get the sectioned view in the top view only. This is the sectioned view. These are called hatching lines. Hatching lines are drawn 45-degree inclined to the axis. Here it is drawn 45-degree inclined to the axis, or we can say it is inclined 45-degree to XY line. This is the apparent shape of section, and if we want to get the true shape, it is to be viewed in this direction. So in first angle projection, this is the method of drawing the true shape of the section. Let us pass on to one question, problem. A pentagonal prism, 30 mm base side and 50 mm axis is standing on HP on its base, whose one side is perpendicular to VP. It is cut by a section plane 45-degree inclined to HP through midpoint of axis. Draw the front view, sectional top view, sectional side view. Also draw the shape of section and development of surface of the remaining solid. Construct a regular pentagon of side 30 mm and drawing its front view, its axis is to be taken as 50 mm. It is said that it is standing on HP on its base, whose side is perpendicular to VP. So one side, that is the side CD, is drawn perpendicular to VP. From that, we draw the front view. These lines are projected upwards and the front view is drawn. The section plane is drawn at an angle 45 degree and passing through the midpoint of the axis. This is the axis. It is inclined at an angle 45 degree. So this is the point O. OA, OB, OC, OD and OE are the distance to its edges, to its corners. To draw its side view, we have to project it to a line drawn 45 degree inclined to XY line. From there, it is drawn upwards and the corresponding points are projected from the left side to right. So this will be A and point A will be here. This point is E and from E we get the point E here. This is the point B, from B, and C from here, and D from here and here. So these points are joined with thick lines. That portion is hatched. We get the top view and side view. To draw the true shape of the line, draw a line x1, y1 which is parallel to the cutting plane. Line x1, y1 is parallel to a1, a dash, d dash. From there, from these points a dash, b dash, c dash, d dash and d dash, lines are drawn perpendicular to x1, y1, and the distance of A from xy is marked from this point. Similarly, this is the point E, or distance of E from this line is marked here. This is the point B. This is the distance from XY line to B. Is marked from X1, Y1 to this. Similarly, D and C. A, B, C, B and E. These are joined with the thick lines and it is hatched. This is the true shape of the sectioned part. You have to draw the development as well. This is a pentagon or a pentagonal prism. So this length will be 30 into 5. One side is 30. Pentagon of base 30 millimeter is given. So 30 into 5 is the length. And its height is same as 50 millimeter, this height. On these lines, the point A is marked here, point B is marked here, point C and D are marked here. This is the point A, point B, point C and D. B and E is the same height, A, and here also it is A. Join these points using straight lines. And this is the development of the truncated portion or the bottom portion. Another problem, a cone 50 millimeter base diameter and 70 millimeter axis is standing on its base on HP. It is cut by a section plane 45-degree inclined to HP through base end of end generator. Draw projections, sectional views, true shape of section and development of surfaces of remaining solid. So its top view is drawn. It is divided into 8 equal parts. It will be better if we divide it into 12 equal parts. We get more points for plotting. It is projected upwards and its height is marked as 70 millimeter and complete the front view. These are generators. If we divide this top view into 12 equal divisions, we get 2 sections here and 2 lines here. So we get 1, 2 and 2 more, 4 generators will be obtained in the front view. Name the points. Top view, this is O and this point is O dash. It is cut by a plane which is passing through the base edge and at an angle 45-degree to HP. So its sectional view can be seen only in the side view. Therefore, the third figure is drawn. The point at which the cutting plane passes through the generators and edges are marked downwards. Third point is from here, and this is the other point. From the center line or from the axis, we cannot get the true length here, so it is rotated or it is projected to the left side, and from there it is projected downwards. From there we draw an arc using O as center and we get the points on OC and OG. Similarly, these points are projected to the right side. And the corresponding points are marked. Join these points using smooth curve and that portion is hatched. Similarly, in the side view also these points are joined using a smooth curve and that portion also should be hatched. So this is the left side view, this is the top view and this is the front view. To get the true shape, we have to project it perpendicular to this x1 y1 axis. For that, lines are drawn from A dash and these corresponding points perpendicular to x1 y1, and the distance from xy to the top view are marked from x1 y1 as done in previous case. So we get many points. These points are joined using a smooth curve. That portion is also have to be hatched. This is the true shape. And we have already understood that cutting a cone in an inclined, using an inclined plane, we get the shape of an ellipse. That's it. To draw the development, take the slanted height, that is O dash E dash as radius, and draw an arc. And this is the angle theta. This is angle theta. Theta is equal to R by L into 360 degree. R by L into 360 degree. R is the radius of the base circle. L is the slanted height or slanted length into 360 degree. So theta can be calculated. From this point to each line A, B, C, D, E, F, G, we can mark the points on the lines. And using a smooth curve, join all these points. We get the development of the sectioned portion. Another problem, a cone 40 millimeter diameter and 50 millimeter axis is resting on one generator on HP, that is lying on HP, which is parallel to BP. Draw its projections. It is cut by a horizontal section plane through its base center. Draw sectional top view, development of the surface of the remaining part of cone. As done in previous case, draw the top view and then draw the front view. It is said that it is resting on one generator on HP, that is lying on HP. So this front view is reproduced here in such a way that O dash E dash is touching the XY line. To draw its top view, these points are projected downwards, and from the top view, these points are projected to right. The corresponding points are marked. This is the top view. It is cut by a horizontal section plane through its base center. So it is asked to cut it with a section plane passing through base center. Draw its sectional top view. So this view is to be produced downwards. These section points are produced downwards to show the sectional view. That portion is sectioned. Its development is drawn taking theta. Theta is equal to r by l into 360 degree. R is the radius of this portion. Length is slanted height or slanted edge, and divide it into the equal number of parts as it is divided, as the top view is divided. Then the corresponding points are marked. And using a smooth curve, this is joined, we get the development as well. Next problem, a hexagonal prism 30 mm base side and 55 mm axis is lying on HP on its rectangular face with axis parallel to VP. It is cut by a section plane normal to HP and 30 degree inclined to VP bisecting axis. Draw sectional views, true shape and development. Hexagonal prism of base side 30 mm and 55 mm axis is lying on HP on its rectangular face with axis parallel to VP. So the top view is drawn and its front view is drawn projecting from the top view. It is reproduced here in a position lying on the ground. Its front view and its top view is marked here. It is cut by a section plane normal to HP and 30 degree inclined to VP. So this plane is inclined 30 degree to VP, bisecting the axis, means it is passing through the center of the axis and inclined at an angle 30 degree. This is the method of drawing. In front view, from here to here it is cut off. So the section is done to that much portion. The true shape of the sectioned portion is shown here. It is also hatched. Development of the hexagonal prism. This is 30 into 6. 30 each. These parts are 30 millimeter each. Corresponding points are marked here, and the section that portion is marked here using thick lines. A solid composed of half cone and half hexagonal pyramid is shown in figure. It is cut by a section plane 45-degree inclined to HP, passing through midpoint of axis. Draw front view, sectional top view, true shape of section, and development of remaining part of the solid. Take radius of cone and each side of hexagon 30 millimeter long and axis 70 millimeter. So this is the views given, the top view and front view. Top view is partly it is a cone and partly it is a hexagonal pyramid. It is divided into 4 parts, the cone. Its development is drawn. It is cut by a section plane 45-degree inclined to HP and passing through the midpoint of axis. This is the axis, its midpoint. Section plane is 45-degree inclined to HP and the points are marked. It is projected downwards to get the points in the top view. So 1 dash, 2 dash, 3 dash, 5 dash and 4 dash can be projected downwards. But for projecting 2 dash and 6 dash, it is to be taken to the side, or we cannot project these points in a line. So it is projected to right side. From there it is projected downwards, and arcs are drawn from this point to either side. We get point 2 and 6. So this is point 1, 2, 3, 4, 5, 6, 7. 7 points. These points are marked in the development as well. As done in previous case, the true shape of the sectioned portion is drawn here. These are the true length of, or O dash 4 dash is the true length, which we getting in OA. In OA we get this length, and for B, C, D and other lines, the true length can be obtained by projecting it to right side. These are marked. Here, please note that C, D, E, F is straight line. So C, D, E, F is joined using straight lines. All other parts are marked using a smooth curve, being a cone. So this is the front view, its top view, the true shape and development. Draw a semicircle of 100 millimeter diameter and inscribe in it a largest circle. If the semicircle is development of a cone and inscribed circle is some curve on it, then draw the projections of cone showing that curve. So draw a semicircle of 100 millimeter diameter and inscribe in it a largest circle. We have to show it on the cone. For that, consider this as the development of a cone. So this is divided into 8 equal parts. That points are noted as 1, 2, 3, 4, 5, 6, 7. Theta, measure theta. Theta is equal to being semicircle, that theta is equal to 180 degree. Theta is R by L into 360 degree. From this, we can find R. And the slanted height is, this is the slanted height. This is the radius. Here it is given as 100 millimeter as the diameter. So we can calculate R. Theta can be measured. And from there, we can calculate R. Taking R, draw the base circle. We get R from this equation, and using that, draw the base circle. Divide it into 8 equal parts. It is projected upwards and draw the front view. This slanted length is obtained from this part, 50. Slanted height is 50. So we can construct the front view. L. Standard length is L. And these points are marked on the front view. First of all, mark these points on the side, and from there it is projected to the generators. Using these points, draw a smooth curve. These points have to be produced downwards to draw the top view as well. Using these points, draw a smooth curve passing through these points. This is the top view. This is the reverse method of doing similar problems. Draw a semicircle of 100 millimeter diameter and inscribe a largest rhombus in it. If the semicircle is development of a cone and rhombus is that of some curve on it, then draw the projections of cone showing that curve. So draw a semicircle of 100 millimeter diameter. Inscribe a largest rhombus in it. If the semicircle is the development of a cone, so divide this semicircle into 8 equal parts. Name it. Measure theta. Theta is 180 degree. Using the equation R by L into 360 degree, we can calculate R. L is the slanted height of the cone. So draw the top view from this R. Divide it also into 8 equal parts. And draw its front view. This length is taken from here, slanted length. Mark these points here. Now these points are plotted. First of all, these points are plotted on the front view. From there, it is projected downwards. To get this point get projected, first of all, it is projected to left side. From there, it is projected downwards. From there, an arc is drawn to get the points on either side. That is line OG and OC. Straight line, two straight lines are here. All other lines are curved. This is the top view. Eighth problem. A half cone of 50 millimeter base diameter, 70 millimeter axis is standing on its base. That is, it is standing on its half base on HP with its flat face parallel and nearer to VP. An inextensible string is wound round its surface from one point of base circle and brought back to the same point. If the string is of shortest length, find draw its projections of the cone. So this is the half cone, half of the cone. Its base diameter is 50 millimeter and axis is 70 millimeter. It is standing on its base or on its half base with the flat face parallel and nearer to VP in this direction. So it is divided into 4 parts. It is projected upwards and the front view is drawn. draws the development of the half cone, and the other surface is a triangle. It is divided into 4 parts, theta r by l into 360. This is the shortest distance, or the point is starting from A and it rotates around it and reaches the point A itself through the back. Find the shortest distance. So this is the shortest distance. We have to draw these points in the first in the front view and top view. These are the points. These are the points in top view. So in front view, it is like this, 3, 4, and from there, from its back side, through its back side, it reaches again to this point. From there, it reaches again to this point. So that cannot be seen here, so it is marked as dashed line. A particle which is initially at the base circle of a cone standing on HP moves upwards and reaches apex in one complete turn around the cone. Draw its path on projections of cone as well as on its development. Take base circle diameter 50 mm and axis 70 mm. So a cone is given, its top view and front view are drawn. It is asked to draw the path of a particle which is moving upwards and reaches the apex by taking one revolution. So a point moves from here and it reaches the top by taking one revolution through this point. We have to draw its path in the front view and top view. This is the development. Theta is equal to r by l into 360 degree. So we have divided the top view into 8 equal parts and divide this line O dash A dash as well into 8 equal parts. And this is the first point of the particle A dash. Second point is here. Third point is here. Fourth point is here. Fifth point is here. And at its back it comes to the top, to the apex. We have to find the path of that moving particle. Second point, third point, fourth point, and fifth point. These points are to be projected downwards. And they are connected using a smooth curve. Similarly, as done in previous cases, these points are to be plotted in the development as well. Join these points using a smooth curve. This is also called a helix, the construction of curve or construction of curve on a cone, which is called a helix as well. Thank you.